So we're just going to hit a couple of highlights for you for section 2.2. One of the questions in your homework is going to be pretty simple. It says if two triangles are similar, then the corresponding angles are equal. So that's the big thing to fill in the blank there. Corresponding angles are equal, and the lengths of corresponding sides are proportional. So this handout shows you essentially exactly what we're just talking about. The ratio of sides in each of these triangles, this corresponding ratios are going to be the same. It's just amazing, though, that all this stuff works, because this kind of stuff allows us to calculate the distance to, say, a nearby star, which we'll work on maybe later in the semester. Now, one of the things that you should have picked up during your previous video is that sine and cosine are really the x and y coordinates of your points on the unit circle, but there's a lot more functions as well. So let's take a look at this particular point, negative square root of 7 over 3 and square root of 2 over 3. That's a point on the unit circle. You could verify that by realizing that x squared plus y squared equals 1. I don't think I'm going to take time to show that. Rather, let's just call this angle, I don't know, what do you want to call it? Theta, alpha, gamma, delta, epsilon, nu, tau. Theta is a very popular choice for an angle. So we'll call this angle theta. And let's see, my point is negative 7 over 3 and square root of 2 over 3. I like writing things in this order. Cosine of theta, sine of theta, tangent of theta. And then across from this, I'm going to write the reciprocal functions. Now, the reciprocal of the cosine is what function? Does anyone remember? Starts with an S.
Secant.
Secant. That's a secant. Reciprocal of the sine function is the cosecant. What's the reciprocal of the tangent function?
Cotangent.
Cotangent. Thank you. So the cosine is which coordinate here? Your x or y coordinate?
X.
The x coordinate. Excellent. So negative square root of 7 over 3. And then it gives us a freebie right away. The reciprocal of this is going to be your secant. Now, the reciprocal doesn't change the sign, so it's still going to be negative. I don't know if Pearson's going to ask you to rationalize that or not. If they do, then what you're going to have to do is take this and multiply by the square root of 7 over the square root of 7 to help rationalize. Now, in the numerator, that would give you negative 3 square roots of 7. In the denominator, you get the square root of 49.
Just 7.
And that's just 7. Perfect. Thank you. Let's do the sine. Sine is going to be, let's see, square root of 2 over 3. And likewise, the reciprocal of that, 2 over square root of, 2 over square root of 3. That has to get rationalized. 2 square roots of 3. What should I multiply by this time?
Is that right? Or is it supposed to be
Root 3 over root 3.
Yeah, I think
square root of 2?
Yeah, okay, and I knew someone was looking wrong.
What is the square root of 2?
3 over 2. Yeah. Thank you. What should I multiply by this time?
Square root of 2.
Square root of 2 over square root of 2. Those are going to simplify as square root of 4, or better yet, just 2. And you'll end up with 3 square roots of 2 over 2. Nice. Last but not least, tangent. Tangent is the y coordinate divided by the x coordinate. So it's going to be square root of 2 over 3 divided by negative square root of 7 over 3. And let me show you one trick that'll make your life easier right away. You can cancel out those 3's. So that's just going to leave you with square root of 2 over square root of 7. The negative didn't disappear from this. If a positive divided by a negative, it's still going to be negative. Now, I'm going to rationalize this. So how would you rationalize this? What do I have to multiply by?
Square root of 7 over square root of 7.
Square root of 7 over square root of 7. Perfect. So they give me minus the square root of 14 over the square root of 49, but that's 7. Last but not least, we got to do cotangent. Let me show you a little trick in finding the cotangent. Instead of starting with this and rationalizing this, which is going to be a bigger mess than we actually need, let me start by taking the reciprocal right here. So the reciprocal there would be negative square root of 7 over square root of 2. And now I'll rationalize that same way as we did before. This time we'll multiply by square root of 2 over square root of 2. Ray, you seem like you're getting really good at that. Thank you.
Thanks.
Negative square root of 14 over the square root of 4. The square root of 4 is just 2. There you go. So a good one there. I like it. Comments or thoughts on that one? You comfortable with this one? There's going to be one like it in your homework.
This was good.
All right. Thank you, Reagan. Now, in this online environment, one of the things that you'll have at your disposal is a unit circle. This is the best unit circle you're going to come up with. It's awesome. It gives you all the angles in radians and degrees, the x coordinates, the y coordinates, and the ratio of y divided by x, basically the tangent. So let's see if we can't use this to do some of the problems that are here initially, at least in some of our practice. So this one says the sine of negative pi over 2. Well, negative pi over 2, I'm hoping that you're familiar with that as basically a negative 90-degree angle. So if you have a negative 90-degree angle, where are you going to be in terms of the unit circle? North, south, east, or west of the center?
South.
Yeah, right down here. Now, sine is which coordinate? Sine is the...
-1.
Yeah, it's the y coordinate, so it's -1. Now, they say you have to do these things, or they say do not use a calculator. Look, there's no way I can enforce that on you. If you're really, really stuck, you can do this on your calculator. You can do it in Desmos. Here's what it would look like in your calculator. I'd like to show it here because you got to be a little bit careful. Right now, my mode is in degree mode. To change that, I'll hit the mode key and then come down and put it in radian mode. Once it's in radian mode, you can hit the clear button. In fact, let me maybe demonstrate it on my graphic calculator over here. And I'm already in radian mode there, so we're good. Let me clear this out and then clear this out so you can see the key history. But for sine, press the sine and then, actually I don't need to hit the parenthesis there. It'd be negative pi divided by 2 should give me exactly -1. And it does. Wonderful. Not a big shock there. But some of these don't work out to be nice, even numbers. So what's going to go on when I have 6 times the tangent of pi over 6? Well, let's see if we can't enlist the help of our unit circle sheet to figure some stuff out here. So pi over 6 is this angle right here. So we want 2 times the sine of pi over 6 minus 6 times the tangent of pi over 6. So that's going to be 2 times the sine of pi over 6 is going to be your y coordinate. So it's going to be 1/2 minus 6 times the tangent. Now the tangent is really the ratio of the y coordinate divided by the x coordinate. And if you did that, you'd end up with 1/2 divided by square root of 3 over 2. The denominators cancel and leave you with 1 over the square root of 3. And then if you rationalize it, you'll end up with square root of 3 over square root of 3 over 3. Cleaning things up, those cancel, give me a 1. Those cancel, give me a 2. I imagine they're looking for an exact answer in a problem like this. So be careful. Unless it says round your answer to something, it's looking for an exact answer. We okay on this one?
Yes.
Yeah.
Thank you. All right. Now, the next one asks for the values, the exact values of the 6 trigonometric functions. They're not defined, say not defined. The not defined stuff typically happens at angles like 0, 90, 180, and 270, not at things that aren't a multiple of 90 degrees. In any case, 600 degrees is our angle, but you should realize something about 600 degrees. 600 degrees is more than once around the unit circle. In fact, it's 600, I'll bring you to someplace over here. So where are you at on the unit circle? I mean, I don't see 600 here. How would I figure out what kind of angle that corresponds to? Well, one thing I can do is realize that once around the unit circle in degrees is how many degrees?
360.
360. So if I go once around the unit circle, that's 360. And then I've got to go another 240 degrees to get to the terminal side of that angle. So it's a coterminal angle with this right here. And now we've got everything. You've got your sine of now 240 or 600, doesn't matter. I guess I'll just write 600. Sine, cosine, tangent, and then the reciprocals. Cosecant, secant, and cotangent. What's the sine of 600?
Negative square root of 3 over 2.
Perfect. It's the y coordinate. So negative root 3 over 2. Cosine then has to be the other coordinate there, which was negative 1/2. Tangent, oddly enough, tangent's positive here, right? It's the ratio of this one to this one, but that's already given to you as a square root of 3. The reciprocal is going to be 1 over the square root of 3, which rationalizes like that. Reciprocal of negative 1/2 is negative 2. And the reciprocal here is negative 2 square roots of 3 over 3. Done. I did the rationalizing for you. Let's skip down to Let's see. Let's do this one next. Cosecant of 9 pi over 10. Says use a calculator to find the approximate value of this expression. So cosecant 9 pi over 10. Let's have at it. In fact, actually, maybe I should start here and just point out something.
The
There's
cyclonic,
no cosecant button on your calculator. This reciprocal stuff does not really represent a reciprocal. It's the inverse sign or arc sign. It has nothing to do with the cosecant whatsoever. So, how are you going to calculate the cosecant then? Well, glad you asked. The cosecant is really 1 over the sine. So if you're stuck and you got to do something like this, hey, 1 over the sine. What mode should my calculator be in? Radians or degrees?
Radians.
Yeah, thanks, Reagan. It's going to be in radians, right? This is in radians, it's not in degrees. So let's go back here. I'll do 1 divided by sine of 9 pi divided by 10. And then you round it off to however many digits that you need. Couple more here.
I have a question.
Yeah, Durade.
Is there any way you can locate the 9 pi over 10 on the unit circle sheet without using a calculator?
No, it's a
Okay.
great question, but not really. I mean, the best thing to think of is that it's 90% of pi, because 9 over 10 is 0.9. So it's going to be something very close to, 180 degrees. Well, not very close. It's going to be somewhat close to 180 degrees, but
162 degrees.
162.
yeah, 162 degrees. So yeah, so if you converted it, you get 162, but it's not a really friendly coordinate on the unit circle. So the only points on the unit circle that are reasonably friendly are the ones that we've got here.
Okay.
And we do a lot of work with those, although obviously that work extends to just any angle, really.
Got it. Thanks.
Thank you. Let's stick with negative angles here, or should we stick with our work on angles? It says find 2 negative and 3 positive angles expressed in radians, for which the point on the unit circle corresponds, or that corresponds to each angle is this. So first of all, let's figure out where that is on our unit circle. So first things first, what quadrant does this have to be in, our point? The point was negative root 2 over 2 and negative root 2 over 2. So what quadrant does that have to be in?
Third.
The third.
Yeah, it has to be in the third quadrant, because the third quadrant is the only place where both your X and Y coordinates are negative. So we can kind of zoom in a little bit on the third quadrant. And pretty soon you see the angle is 5 pi over 4. That's in radians. Now, I'll do this a couple different ways. Let's first of all think of it in degrees. So 5 pi over 4, that's our angle in radians. It's 225 degrees. But if I wanted to get to that angle, so here's my unit circle, 5 pi over here, 5 pi over 4 is here. I can go right there, or I could go right there or I could go once around the unit circle and then go right there. So that additional lap around the unit circle is like adding 360 degrees to that. So that'd be 585 degrees. So that's one positive. This is the second positive angle. And I think the problem asks me for a total of 3 positive angles. How would I get another one?
At another 360, right?
Sure, add another 360. So adding another 360 would take me up to 945. And now I've got my 3 positive angles. How do I get a negative angle? What am I going to do there? Well, what I want to do is I want to start out and go this way. So if I subtract 360 from that, so minus 360 should give me negative 135. So 225 minus 360, negative 135. So one negative. I need another negative angle. So that means going here and then another 360 around there. What do you suppose that's going to be? Negative what? Or how would I get it anyways?
It'll be negative 495.
Yes. So you're just going to take this and subtract another 360. And that'll give you 495. So in case you're curious, you can hit the minus key and then subtract 360. Yeah, you get 495, negative 495. And that's your second negative angle. There is one downside. Although this is more intuitive, it does leave you with a little bit of work to do. It's because you've got to do this in radians. Your answer has to be up here in radians. We've only got one answer in radians. So how do you do this in radians? Well, to get from one to the next here, what's the difference between all these angles? How many degrees are in one trip around the unit circle? Once around the unit circle is 360 degrees. 360 degrees in radians is what? What's once around the circle in radians?
2 pi.
2 pi.
Or 1 revolution?
For
Or is
one
that-
revolution is 2 pi. Now, could I also write that as 8 pi over 4? Is that the same thing?
Sure.
Yeah, 8 over 4 is 2, so that's the same thing. Does anyone see the benefit of writing it as 8 pi over 4?
No.
Because it's the same as 5 pi over 4?
Yeah, they have common denominators. So if I take this and add 8 pi over 4, then I'll get 13 pi over 4. And that's another positive angle that has the same coterminal angle as 5 pi over 4. What if I added another 8 pi over 4? What would this next angle be?
Twenty-one.
21 pi over 4. And so these are my angles so far. Those are all in radians. Now I've got to go the other way. So instead of adding 8 pi over 4, what do you think I'll do to get this next one?
Minus.
Minus, fale mandare. So minus. So that gives me negative 3 pi over 4. Right? Because 5 minus 8 gives me negative 3. And then I got to do it again. Negative 3 minus 8 gives me negative 11 pi over 4. So These are the 5 answers that you'd have to type in. And you can do that, you know, maybe you're the one that you see in your homework is going to end up with pi over 6 or something like that, but it's the same idea. If you had to add something and your term up here was pi over 6, then you can write 2 pi as 12 pi over 6, and then do the same thing there with what we did here and pi over 4. All right, so that's probably one of the harder ones that I would envision that you'll see in the homework. How are we looking on that one? Doing okay?
Good.
Doing good. All right, good to hear. Are you comfortable with these? Do you want to do a couple more examples of some of these simpler ones like cosine of 60 minus sine of 45 or cosine of pi over 4 or tangent of pi over 14? Okay. Well, let me call it a day on this and then put you in your breakout rooms. So kind of a little bonus problem here for us. Cosine of 15 pi over 2. Now, there's nothing really wrong with just typing this into your calculator or to Desmos and getting an exact answer really quick. But let me help you understand the intent of the problem. The intent of the problem is to understand where this angle is and then to find the cosine there. So let's take a look at 15 pi over 2. And I'm going to start by converting that to degrees. So let's think about what that's going to mean here. To convert to degrees, I know that there's 180 degrees in every pi radians. So I can multiply like this. That's going to give me the pi's canceling out, and then the 2's cancel into the 180, gives me 90 times. So put a 90 up here. 15 times 90, that's 1,350 degrees. That's clearly more than once around the unit circle, isn't it?
Right.
That's once around and changed. So I can subtract off 360. So we'll take 1,350 and subtract off 360. 1,350 minus 360. And that's still more than once around. So I'll subtract off another 360. And then another 360. And finally, I've got something that's within the unit circle in terms of degrees, right?
Right. Okay.
And it's 270 degrees. And from the unit circle, we know that the cosine is the x coordinate here, and that's going to be a 0.
0.
So cosine of that would be 0. You could play the same game if you wanted to do that in radians. Now, it's a little bit harder in radians because it's not a nice even 360.
Mm-hmm.
But if you're working in radians, 15 pi over 2, you could call that 7.5 pi. Once around the unit circle in radians is 2 pi. So I subtract that off and I end up with 5.5 pi. And well, that's still not enough. So subtract off another 2 pi. And that gives me 3.5 pi. Well, I'm getting closer. And subtract off another 2 pi and end up with 1.5 pi. 1.5 pi is 3/2 pi. And that's in radians what 270 degrees is, or what 270 degrees is equivalent to 3 pi over 2. It puts you at the same point on the unit circle. The x coordinate is 0.
Okay.
All right.
Just kind of just break it down for the most part.
Yeah. I mean, the idea is to understand basically that this angle and this angle, or this angle and 270 are coterminal angles. That's putting you at this point. And then it's just the x coordinate there. All right.
Okay.
Cool. Anything else on that one? All right. Good job. Thank you.
Thank you.